Everybody, we're back with another LaserTRAM-DB video. This one's going to be a little bit shorter, and it's going to go over how to deal with normalizing a line of spots gathered in quick succession. Say you have something like a rotating aperture, or a way to generate a bunch of spots that are gathered in succession rapidly enough that you don't really come down to background, and you can't parse those out into individual files. Or the instrument doesn't parse them out into individual files. So we're going to start with firing up LaserTRAM again. Remember, just go to the command line and activate the virtual environment that you're in. And then cd into the folder, and then so you can run this script from your favorite IDE as well. So we're fired up, and LaserTRAM-DB is always going to open in the New Project tab. It's always going to default to spot analysis because that's the most common thing that we're doing. So when it fires up, go over to LaserTRAM Profiler, and you'll see that it looks very similar. And so for a quick refresher on what LaserTRAM is doing and the overall organization, you can go see that video. But in the same way, we're going to upload our data. And this is going to take the same format as our line of spots data, where it's a column for the timestamp, a column for the spot name, and all of our counts per second. And what you'll see here is that it's actually not one spot, but it's a bunch of spots gathered in quick succession. And you can tell them apart, but they don't actually come down to background all the way. So it requires a little bit of finesse in extracting each one of these profiles. If you have something like an Eris transport tube that allows you to get down to background easier, it can help you distinguish between those. That's what this was gathered with. But even if you don't, you can still use this to chunk out different portions of your transect. And so just like LaserTRAM spot analysis stuff, you're going to choose your background interval with the left two sliders, and you're going to choose your actual interval of interest with the right two sliders. And what we see here is now we're on our first spot, and we can go ahead and record that. So now this, instead of going record into the next sample, it's just going to stay there. And how we're going to be able to essentially peak hop is by controlling this step size thing here. We can also drag the sliders over to the next spot there if we really want to. It's a little bit tedious, but it's possible. Okay, we're good. We got our next thing. But what we can do is we can use this step size thing and this backwards and forwards button here. Because I've done this example before, I know kind of the sweet spot is 13, and when this is basically seconds that it's going to jump along the profile. So when I hit forwards, we'll see that now that interval is going to jump 13 seconds and basically be right on the next peak. When we go backwards, it'll be on the backwards one. And so we hop forward like that, record, hop forward like that, record. That one gets a little bit too far forward. We can adjust our profile back a little bit. It's never going to be exact, but we can record that, and we can keep hopping down the line and recording and going backwards, etc. So this is going to give us the ability to kind of navigate through here in a relatively easy fashion while still giving us the time resolved control that we would like. And what you'll see is that now we have our profile name here. This is a 8th OG analysis, the 7th one. And what we can see with each step that we record, as we incrementally go down this line, it's adding another number onto that. So we know that it's the first, second, third, fourth, fifth, etc. on down the line spot in that line of spots. So it can kind of help us with. And it's also adding the requisite time to the timestamp. So, we have a timestamp for this analysis at time 0. This one is going to add something like 85 seconds onto the end of that. So you'll always know, they'll always order themselves, based on their timestamp, even if the numbering gets a little screwy and I went back and, recorded this one again, it would be the requisite timestamp. So the timestamp is always going to be a nice unifier for us here. And similar to the LaserTRAM spot analysis, we're just going to go ahead and export this when we're done and save it. I'm not going to do that. What I recommend for this is doing one profile at a time. You can strap a bunch of profiles in one Excel spreadsheet and do that if you really want to. Those spreadsheets can get pretty big pretty fast because we're dealing with a lot more data here. And like I mentioned in the LaserTRAM spot analysis video, all this data is being stored in the web browser. And so that comes at a cost. The web browser doesn't like to store massive amounts of data, and Dash can't really handle, the thing that builds this dashboard can't really handle huge data files, or it gets quite laggy when you do that. So if you don't want to be lagging too much, and also you don't want to process too much data at once, I recommend, a few profiles at a time. Or just doing one at a time here. And you can see then it's pretty fast and instantaneous to load stuff in, and a little bit easier from a file management standpoint. And then when you're done, you can take all of these outputs and then strap them together for something like LaserCalc.